When we want to measure the discharge of a stream indirectly, we may use some hydraulic structures. Some examples of those structures are weirs and flumes. These structures produce unique control section in flow, which enables us to express its discharge as a function of upstream water surface elevation. On top of that, the flow behavior may be affected by the downstream water level if it is above the limiting water level, namely the modular limit. In this case, we will be encountering a submerged flow condition. On the other hand, free flow condition is induced if downstream water level is below the modular limit. Under free flow condition, the function of discharge can be transformed into a power function of head over the weir h. Both k and n are the system constants. A flow measuring structure will normally fall into one of the following categories. One of them is a thin plate structure that forms a sharp-crested weir using metal plate. Apart from that, there is broad-crested weir, which usually constructed using concrete and masonry. Lastly, it may be categorized as a flume. Concrete, masonry, and metal sheets are used in forming this structure and produce control section via width constriction. If we want to use a more versatile stream flow measurement method, we may opt for slope area method. This method utilizes Bernoulli's principle, while categorizing the stream flow as uniform flow in an open channel. Under the principle of conservation of energy, the head at the upstream equals to the sum of the head and head loss at downstream. Total head loss may then be expressed as the summation of elevation and velocity head differences. Head loss itself consists of two components, namely friction loss and eddy loss. Eddy loss is a function of absolute difference in velocity head. For open channel, Manning's equation is used to determine the flow discharge. From this equation, we can express the energy slope as a division of head loss by the length of reach L. Let K be the conveyance of the channel, and we can simplify the equation. Where non-uniform flow is considered, we need to use average conveyance in our calculation. The calculation for discharge using slope area method is an iterative process. Let's say we are now inspecting a rectangular channel. The width of channel is 10 meters, while the depths of water at upstream and downstream points are 3.2 and 2.8 meters respectively. Both points are 340 meters apart, while a drop of water surface elevation, which is also known as the fall of 0.15 meters, is observed. Given the Manning's coefficient of 0.025, we are required to estimate the flow discharge through the channel. First, for point 1 and 2, we need to calculate the cross-sectional area, wetted perimeter, and hydraulic radius of flow. With these values, we can then proceed with the determination of conveyance. For subsequent steps, we will use the average conveyance. For uniform flow cross-section, eddy loss should be taken as 0. For our first trial, the head loss is assumed equal to the fall, which is 0.15 meter. To solve for discharge during our first trial, we first require the energy slope. After dividing the head loss of 0.15 meter with the reach of 340 meter, the slope equals to 4.41 times 10 to the power of negative 4. Then, by implementing Manning's equation, the discharge would be 38.19 Qmax. Based on the principle of continuity, the discharge should remain the same for both points. The flow velocity across the section, on the other hand, is a division of discharge by the cross-sectional area of flow. The velocity head for upstream and downstream points are therefore equal to 0.073 meter and 0.095 meter respectively. Based on the Bernoulli's principle, head loss equals to the summation of fall, velocity head difference, and eddy loss. The observed fall is 0.15 meter, while eddy loss is 0. As a result, the head loss calculated using Bernoulli's principle is 0.1278 meter. Significant difference is observed between the trial and final head loss value. Therefore, we need another iteration. For the subsequent trial, we will take head loss equal to 0.1278 meter. The steps are repeated until the head loss calculated from both equations shows negligible difference. Only then, the convergence is achieved, and we can conclude our trial and error process. For our example, the flow discharge calculated using slope area method is 35.63 cubic. Thank you for watching. If you find this video helpful, please share it with your friends. We'll see you guys soon. Goodbye.